Unit 6, Lesson 4. Let's see here. This is going to be... All right. Okay, so we're doing second part of your angle measure from trig ratios. So lesson 3 was the trig ratios. We talked about the 6 main trig ratios: sine, cosine, tangent, cotangent, cosecant, and secant. Okay, and so angle measures, when you're trying to find degree, this is kind of how you figure out how to find degrees. And we did mention it during last time we were talking about when we'll use the inverse, because you guys are thinking that inverse was the same as the like sine and cosecant were inverses when they're reciprocal forms. Okay, and so use the following procedure to determine the angle measure between 0 and 360 given a trig ratio. So what you do is you determine the quadrants the angles will be in by looking at the sign for the ratio. So this is where you have to know the cast rule, because a calculator will usually give you the positive sign. You just have to know where you're at. Okay, so that's what it's telling you. So you got to figure out, are you expecting a positive or negative answer with the cast rule? Okay. Second thing is determine the reference angle, always between 0 and 90. So draw a rough sketch, appropriate quadrant, then determine the reference angle. Use second sine, second cos, or second tan, okay, of the absolute value of the given quality. So when you're doing it, you're going to essentially take the positive piece, but we know if we're expecting a negative or positive. Okay, so it's like we're going to using inverse sine. This is when you're solving for degree measure. Okay, so that's what they're walking you through. Determine the rotation angles using the reference angle and the quadrant you're supposed to be in. Okay, so make sure to check the given domain, because sometimes they'll say, hey, we only want half the circle, okay, or we only want between 90 and 180, so we only want the second quadrant, right? That 90 and 80 be the second quadrant. So you got to make sure you're looking at the given restrictions. So the first one, they give us the full circle for the restrictions. So it says complete the following to solve cos theta of negative 0.5. So what we're going to do is where is cosine negative? So cosine, we think x. X is negative on the left. So what quadrants are on the left? 2 and 3. So 2 and 3 is our possible quadrants we're looking at. Okay. To find the reference angle, you're going to type in now. It's like you're solving. You're going to go cos inverse to get that to go away. You're going to type in cos inverse negative 0.5 into your calculator. Okay. And what's the reference angle of 120, though? Not 30. Yeah, so you're right. You got 120. So 120 is right here. Right. 60, right? So 60 is that reference angle of 120, because 120 is right here. Has to have 180. So good. So your reference angle is 60. That's what this is asking. In quadrant 2, the rotation angle is 120. In quadrant 3, what's the rotation angle? So we're getting our possible answers here. Yeah, 240. Okay, so let's walk through this. We know cosine's negative. So we know our spots have to be in quadrants 2 or 3. Okay, our possible answers, okay, are right here, 120. Because 120 is in quadrant 2 with a reference angle of 60. The other one with a reference angle of 60 in quadrant 3 is right here. So 60 plus 180 gives you 240. So that's where the 240 comes from. So 240 and 120 are negative cosine of 1/2. Okay, any questions? Okay, what's wrong, Keegan? The second what? This line? Because reference angle is 60, so I went 60 away. Because we know reference angle is 60, we know our values are in 2 and 3, so we want 60 and 60 away from both sides of it. Yeah. Okay, any other questions? And the reason we're doing the 1 and 3, Keegan, is because in the beginning we said the answers can be in 2 or 3 because it has a negative cosine. Okay. So then example 2 says given that sine theta squared can be written as sine squared theta. Solve the equation for sine squared theta is 0.5. So remember we talked about this. Remember that's not the same. You have to have the brackets. That means theta squared. So they're making sure you see the difference. So sine squared theta is the whole thing squared, the whole sine of theta. So this is not what we're talking about. Okay. So essentially we have to do what for solving for sine theta? Well, if this is this, and we're trying to solve for theta, what would we do to get rid of a square? Square root. So square root's the first step. And so we're doing that, we have to do plus or minus. So now it's going to be sine theta equals plus or minus 0.5. And then now we do sine inverse. So sine inverse, well, before we do that, plus or minus, right? So what's that mean? Our answer can be anywhere, because it's a plus and a minus. So sine's plus or minus in all 4 quadrants. So that means we're going to get all 4 rotation angles that could be possible here. Okay, because all 4 could be positive or negative, obviously. That's the only options. Okay? And then see, it does tell me to go the full circle. If it just said, let's change the domain here. What if I said just to 180? 0 to 180, then how many answers do I have? 2, right? Because I'm only doing 2 quadrants, 0 to 180. Okay? So all we do now is we sine inverse. So we go sine inverse of negative 0.5, sine inverse of just positive 0.5 rooted. It's not going to matter. You only need one of them. I'd just do the positive if I were you. So what is sine inverse of root 0.5? What is it, 45? Yeah, so it's 45. So 45 is all we need, guys. 45 is a what? That's our reference angle. Okay, because it's where? It's in quadrant 1. It's right here, 45. So that means I want 45 on all 4 spots. So 45 for the first one. Then what's the second quadrant's 45 cut? So it's halfway between 90 and 180. 135. Halfway between 180 and 270. 225. And the last one, 315. That's your 4 possible solutions for sine. So right there, we're using trig ratios to solve. Trig ratios to solve. So again, important piece is it a positive or negative? Okay, that tells you what quadrants to look in. Find the reference angle using the inverse. Okay, and then figure out from the reference angles what answers are possible. That's your steps we're walking through. All right, so this is the page I don't have with me, but that's fine. We'll be able to do it here. Okay, so angle measure in degrees from reciprocal of trigonometric ratios. Can't say it right now. Okay, since there are no calculator keys for cosecant, secant, or cotangent, we must rewrite the reciprocal ratios in their primary form. So that means we have to write them as 1 over tangent. Okay, so if cotangent x equals root 3, we rewrite it as tan x equals 1 over root 3. Just flip, flip. Okay, does that make sense? Because you don't have a cotangent button. Okay, so it says solve cotangent x of root 3. And I like they're using a lot of stuff in the unit circle right now because we're doing unit circle today, so this is good. But cotangent x of root 3 means tangent, tangent x of what? Right. And then we simply just do what now? Inverse tan. So we're going to inverse tan both sides. So we get x equals tan inverse 1 over root 3. Just keep that in brackets. Okay, can somebody do that for me? 30, okay. So 30. So we're not quite done yet because it wants from 0 to 360. Cotangent and tangent, they have the same properties in terms of where they're positive, where they're negative, right? Okay, so my point is that we're doing, where is tangent positive? First and third, yep. Here and here, right? C-A-S-T. Okay, so 30 is an answer because that's quadrant 1, right? What's going to be quadrant 3's? 210, good. 210 because that's 180 plus 30 gets you 210 here. Okay, so 30 and 210 is your solutions. Okay, any questions on that? Okay. All right, go and try these ones. Determine the measure of x to the nearest degree. So they're giving you the inverse one still. So secant's the inverse of what? Cosine. So you're going to do cosine, cosine x equals 1 over negative 1.2631. And then cosecant, you're going to do sine x equals 1 over 2.45. Okay, and then inverse from there. Go ahead and try to calculate that. I'm going to pause the video, let you do that. All right, so what do we get for the first one? Get anything? So you should have put cos inverse like that. $142. So it does say absolute value, so go ahead and put the positive in. Don't put a negative. Put positive in. And you're going to see kind of what happens here. You got 142, which is going to be okay. 30, but the 38, right? Okay, so I just want to show you what they're talking about with absolute value, guys. If you just put the absolute value, what it's doing is it's giving you the positive reference angle. Okay, if you put the negative, where's cosine negative? It's negative in the second quadrant, right? So it's giving you the second quadrant answer. So cosine, that works. But for sine, well, the problem with sine is it goes past 180, right? So it's probably easiest, that's what they're saying, is to always just put that as a positive, because we know we want the negative spots. Does that make sense? If you put that as positive, it's going to get you the positive reference angle. Is 38 one of my answers here? You fell for the bait. It's not, because 38's in what quadrant? It's right there. But what do we want? We want negatives. So we want over here. Cosine's negative on the left, right? So my solutions are coming from the left side. You still can use 38. 38's really important. That's your reference angle. That's everywhere. Okay? So 142 is one solution. Okay, this is your reference angle, not your answer, though. Okay? You can write that in your notes. Not an answer. Okay, this is an answer. That's in quadrant 2. And what's quadrant 3? Is you go 180 plus the 38. Right. So you put, this is 38 degrees right here. So 180 plus the 38, yeah, 218. So 218 is my other answer. So 142 and 218 are my two solutions for secant of x there. Okay. Any questions? All right, I'm going to erase this. Well, I'm just going to erase it. I'll leave this stuff up here. Let's take this back a little bit. Okay, 142, 218. Let's try the next one here. So sine x, you should have put sine inverse of 1 over 2.45. What do we get there? 44. Now, I'll ask the question again. Is 44 one of our answers? 24? 24 or 44? 24. I just heard wrong? Okay. Is 24 one of our answers? Yes, because I have sine of a positive and 1's a positive quadrant. Where else is it positive? 2. It's going to be positive here and here. So what do? 180 minus 24, right? 180 minus 24, 56. 156 is your other solution. So this is what I'm talking about, that mental math stuff, guys. Find your positive, negative. That, you know, you're going to be going from 180 and 360 and 90 and 270 a lot. So there's that mental math should get kind of decent. 24 degrees and 156. All right, so down here at the bottom, they threw a couple different ones at you. Okay, so cosine theta equals 0. So then we're thinking, okay, cosine theta equals 0. So where is, okay, let me back up. Cosine, I said, goes with what variable, x or y? X, good Lord. So it goes with x. So then my next question to you is, when you're going around, let me move this up. When you're going around, you know, our grid, what locations just tell me the degree measure, is x0. Where is x0? The y-axis, right? Here and here. Well, what are those degree values? 9270. That's it. Okay. What does this do? I forget. What does it do when you do inverse cos of 0? Does it tell you 90? Yeah. 90. Okay, so now it's saying cosecant is undefined. What does that mean? Well, cosecant is what? Cosecant is 1 over sine. So it's essentially asking me, when is sine 0? Because when sine is 0, that's undefined, right? 1 over. So where is sine 0? Sine goes with y. So which spots? 0, 180, and you could put 360 too because it says include 360. So 0, 180, and 360. Okay? 0, 180, 360 will all be undefined for cosecant theta. Okay? Because that's when sine is 0. Whenever you see undefined, guys, remember that's non-permissible. That's stuff that we've already dealt with. All right, let's keep going here. All right. Okay, angle measures and radians from trig ratios. So similar procedure can be used to determine angle measure in radians by setting the calculator to radian measure. So right now, everybody's in degree mode. Okay, you can go to radian measure. So again, we still determine the quadrants the angle will be in, so we can figure out the sine. Determine the reference angle in terms of radians. Okay, and then draw a sketch of appropriate quadrants using your second sine, second cos, or second tangent. You do the absolute value of it. That just gives you the positive reference angle, which we can use in any quadrant. Okay, and then you determine the angles using the reference angle of the quadrant. So again, if we do the positive of every time and we do that inverse, it's going to give us the positive reference angle. Whether we're here or not, we need to know. Okay, let's just review. We already have this in our notes. Okay. All right, let's look at these ones. In each case, determine the values of theta to the nearest hundredth of a radian. So what that means is that pi is calculated in. So we're not going to write 2 pi over 3. It wants, go ahead, nearest hundredth of a radian means that pi is multiplied in. Okay, so we have a value. All right? So then what we have to figure out here is, this is between 0 and 2 pi, so what's that mean? Yeah, it's all the way around, right? So then we're just going to go simply cosine inverse of positive 0.5. Okay, what's cosine inverse of positive 0.5 in radians? Make sure you switch to radian mode on me. 0.047? 1.0. Okay. Is that what you're saying? Okay. Did everybody else get that? Okay, good. Now, 1.047, how can we figure out in radians what that is if we wanted to figure out the actual radian measure? What would we think about doing? So 1.047. That's our positive reference angle, right? Let's just stay simple here. Actually, I won't talk about the other part. I'm going to try to keep it simple. That is our what? What does that represent? Let's just stay simple. Okay, yeah, it's our radian measure, but more specifically, it's our radian measure for what? What did we do previously? That first thing we got was always the what? Reference angle, right? This is our reference angle in radians. This is our reference angle in radians. I was going to say that, but we don't actually have to do that. Okay? This is what you have to do. We want cosine to be negative. So again, where's cosine negative? 2 and 3. So then, if this is my reference angle, what is this spot here in radians? Pi. So I'm going to go pi minus 1.047, pi plus 1.047, right? Minus for that one, plus for that one. That gets me my 2 spots on 2 and 3. You're doing the same thing you do with angles, guys. It's just in radians. And the part that you were saying, Donovan's going to come up on the next page. where if you get the exact radian measure, which means we're not going to have pi as a decimal. Okay, can somebody give me these? .09 what? Sorry? 4, thank you. Okay, good. Okay, so a couple things you can think about, just so you know that you're right. We know that we should be in quadrant 2, right? Quadrant 2 is 1.5 to 3.1. 1.4, right? 2.09 is between those, so we're in the right quadrant. 3, 4.189, this is 3.14. This is like 5 point something. 3.14 and 5 something, 4 is between that. So we are nowhere in the right quadrants in terms of decimals. Just kind of think out loud. How do you know what those spots are? Guys, you simply use your calculator. What is pi divided by 2? What is 3 times pi divided by 2? Those values, and then you have pi. You can just see if you're between those values like you're supposed to be. Okay, that's what I'm talking about. So, and then what Donovan's talking about is that if you have pi in an exact form, so it's not as decimal, which I think is easier to see, but this is what they're asking for right now. Also says it's nearest hundredth, so this would be 2.09. This would be a 9 here, if you actually do what they said in directions, 4.19. Okay, cotangent theta. So cotangent theta is tan theta of what? -4 over 5. So then, before we go any further, which quadrants are we going to be in? Tan is negative. 2 and 4, good. So that's where we're getting our answers for 2 and 4. So now what you're going to do is you're going to go tan inverse of just 4/5. Oh, except for I didn't read. What did it say? So we're not going to get 4. 4 is not included. We only get one answer. Good, good, good. So tan inverse of just 4/5. Just do positive 4/5. That's the positive reference angle. What do we say? 0.674. Okay. So tan inverse of 4/5, you said is 0.674? Yeah, so that's cotangent. And so tangent is the flip, right? So we flipped. Yeah. 675. Okay. So 675 is your positive reference angle. So how do we finish? What do we do? Pi minus 0.675. Good. So 0.675, I know this is weird looking, but 0.675 is right there. We want it over here in quadrant 2. So we're doing pi minus that value to get our radian measure for that location. We're not including 4 because our restrictions said we're 0 to pi. Okay, so what is that, like 2.4, 2.3? 2.47? Okay, any questions? Oh, how do you think that back to degree? So what's our form for degree? 180 over pi, right? So you times it by 180 over pi. Go ahead and do that. Aiden, what is that? 2.47 times 180, then divide it by pi. 141. So let's think about that for a second. So Aiden asked us to convert that to degrees. 141 to 141 degrees. Guys, here's the full understanding. We've got to get our head wrapped around this idea. A couple things I want you to know is 2.47. That's less than 3.14. I feel good about being in quadrant 2. 141. That's between 90 and 180. I feel good about being in quadrant 2. Okay, that's where I'm supposed to be. Okay, so these reflect that I'm in a good position. Okay, where I'm supposed to be. Okay, all right, cool. I think that's probably the easiest thing. That's what they tell you to do, is to drop the negative, find the reference angle, just know where you're going with it. Yeah. Okay, trimming angle measure as an exact multiple of radians. This time we're going to keep the pi involved. Okay, so in class example, we solved theta as -0.5. The reference angle is 60, and the solutions are 120, 240. Converting that to radians, it's 2 pi over 3 and 4 pi over 3. We know the solution is, in that case, 2 pi over 3 and 4 pi over 3. Those are locations on our, it's on the unit circle, actually. In class 4A, we solved cosine of negative 0.5 pi, and we got the nearest hundredth. The reference angle is 1.047, which we got. The solutions were 2.09 and 4.19. We can determine the solution's exact multiple in radians by doing the following. So this is exactly what Don was asking. How do we have radians in our answer, or pi's in our answer, excuse me. Divide the reference angle by pi and convert the answer to a fraction. So you're going to divide it by pi and then convert your answer to a fraction. Okay? Then you'll determine your rotation angle using the reference angle and the quadrants. Okay? So here's an example right here in the screenshot of the calculator. So cosine inverse of negative 0.5 is 1.047. Divide that by pi, and then hit the fraction button, 1/3. So it's pi over 3. Yes? If the numerator isn't 1? Then it will, yeah, so if it was 2/3, it'd be 2 pi over 3. Yeah. Does that make sense? Okay. All right. And so then, but remember, because pi over 3, though, pi over 3 is our reference angle, right? So what they're doing is this right here gives you your reference angle. So that's a reference angle, so you won't get 2 pi over 3, actually. That was just an example. Pi over 3 is what we'll add or subtract to pi. And so then we're just going to combine, like we're going to do fractions, right? 1 plus 1/3, that's what that is. That's 4/3, right? 1 minus 1/3, that's 2/3, okay? So that's what we're doing there. Okay, let's go ahead and try it. All right, this is the last set, right? Yep. Okay, so sine theta of 1/2, okay? So what quadrants are we going to be in? 1 and 2, good? We're here and here. Okay, good. We're going to sine inverse 1/2. Okay, you're in radian mode in your calculator still. Yeah, we're doing radian measure. Okay, and then you're going to divide that value by pi. Good, 1/6. So that means the reference angle is pi over 6. So Don, we got 1/6. That means your reference angle is pi over 6. Does that make sense? Okay, pi over 6, is that an answer? Yeah, because we're in quadrant 1. That's right there. That is one of our answers. So pi over 6 is an answer. Then we have to go what to get this one? Pi minus pi over 6. Okay, 6 over 6 minus pi over 1 over 6 is 5 over 6, right? 1 minus 1/6 is 5 over 6. Let me say it again. 1 minus 1/6 is 5/6. You're just taking a sixth away. So these are your two radian answers, pi over 6 and right, because we're actually bringing the pi back. Say that again. Right. So Keegan, this might answer your question. So if you're saying, well, why are we dividing pi out? What we're doing is we're dividing pi out to see what the fraction is, and then we're sliding it back on. We're dividing pi out to see what the fraction is, and then we're going to slide the pi back on as pi. So we're dividing it out to see what's there without it, and then putting it back on there as pi. That's what we're doing. If you're wondering we're dividing pi out, how do you just bring it back? We are. We're taking it out and sliding it back in, so we get back to where we were. Okay? Yeah. So 5 pi over 6 is the rotation angle? In radian measure, yeah. It's the rotation angle for radian measure of locations in quadrant 2. Okay? All right, secant theta of negative root 2. So secant, so that means we really want what? Cosine of negative 1 over root 2. We flip it. Okay? So then what you're going to do is, what quadrants are we in? Quadrant, negative cosine is 2 and 3. Yep. Quadrant 2, quadrant 3. And now we're going to go cos inverse. Just do the positive to get the positive reference angle. Good. You get 1/4, which means your reference angle is pi over 4. Okay? Your reference angle is pi over 4. Is that an answer? No. We want 2 and 3, quadrant 2 and 3. So your answers are going to be, so answers, in 2, it'd be pi minus pi over 4. In 3, it'd be pi plus pi over 4. So 1 minus 1/4 is 3/4. So 3 pi over 4. And 1 plus 1/4 is 5 pi over 4. So 3 pi over 4 and 5 pi over 4 are your solutions for that locations. All right, and another one of undefined. This one, you just have to know your radian spots because you can't plug undefined in your calculator, right? So when it says cosecant undefined, you immediately know division by 0. We know that cosecant is 1 over sine. So we are trying to figure out when this is undefined. It's undefined when sine is 0. So where is sine 0? Here and here, right? What are those radian values? 0, pi, and 2 pi. And that's it. 0, pi, and 2 pi, and that's it. Okay?